use it.
Hi everyone, welcome. I'm Vivian. I'm the organizer for this meetup. I teach half of their meetup events. And welcome. And this is the second Hadoop one. So how many of you finished all the tutorial on GitHub repo? You have 3 instances running now. Okay, cool. And I know 3 of you are here first time. So do you want to sit with someone else? They already configure everything. Because you are like already 2 hours behind of everyone. I record the previous one, so you can watch the video and pick it up. Please, who finished all? Can you raise your hands again so people can find you and sit with you? Come on, it's all about help each other. Please, if it's your first time here, can you sit with someone already configure their environment? So I want to ask you, what should we do today? Like last time, it was like I do one step and you do it, follow me, but it's really slow. Do you want me to show you all the steps so you can configure things on your own?
I think that would work better, personally.
Okay. So where are you now? Tell me which step you're now.
We had session to each of the instances.
Exactly. Have you copied all the RSA to each host?
No, we didn't do that yet.
Yeah, to all the authorized keys.
Have you configured the private DSN for each host?
Mm-hmm. Yeah.
Have you tried to ping each other?
Yeah.
Does the ping work?
Yeah.
Awesome.
Not
So they're way ahead of me. So.
Doesn't necessarily.
So, permission denial. Which step you got?
Okay, the public key, I think, okay, how did I solve that one?
So this is my GitHub repo. I post the first events tutorial. Basically, you can follow them step by step. In the end, you should have your own cluster with 1 master node and 2 slave nodes. And today, I want to cover how you can really do things, like run your MapReduce job. So, if you have already, so can we do, where should I start today? Which step you prefer me to get started?
I'm on number 2 in this section, or 3, but I don't know where everyone else is. Or 2 on 2.
Yes,
I think some of the instructions got a little messed up, specifically starting in the second bullet.
Yeah, if you view the file in raw mode,
Yeah, I was
what will
thinking
happen is the markup processor step the HTML tags.
Yeah.
Oh, so you can click on the editor. You can see the
Yeah,
resource.
just click on raw.
If you do the raw.
Show
Yeah.
the text, like raw file, literally.
Yeah.
Oh, I see. Because when I do the configure file, I told you should put this section inside of the configure text.
Yeah.
When Markdown translated,
That makes
lost.
sense.
Yeah.
So maybe click on the row.
Scroll to the big.
Okay, so I suppose everyone finished the Java one, right? The set up your Java home. Where are you now?
Well, yeah, my machine just came up, so. If you restart the DNS. Yeah, if we restart those, DNS change.
Okay, how about this? Guys, I will demonstrate the MapReduce on my machine. So after I finish all the explanation, I can walk around, help you to set up based on my tutorial. Does that work better?
That sounds good, yeah.
Okay, cool. So I restart my notes. You should have 3 too. Just select all of them, do action start. And right now you only need to access your master node in order to run MapReduce work. So last time we was at the configure server, there's one more step before you can use Hadoop. So you need to install your R. Those are the commands you need to run, 4 of them. Sudo sh, sudo adapt key, sudo get install. Next, you want to install RJava and other packages, including lib. Also, I asked you to go inside of the environment file to add those lines of code. Next, you should run your source environment. That means reload your environment setting. So after you have the RJava, I give you a code called install packages. RJava code tool, RCPP reshape, iterator tool, digest, RJSON.io, functional, bitop, how to say that? CA tools. Those are the dependent package for RMR2. That's the MapReduce package. And next, after you have RJava and dependent source code, you should keep install the RHDFS, RMR package. And there are 2 MapReduce jobs you can run. So after you have all the packages, you can copy paste this part and run in your R. The first one is like calculate what's the number for square 1 to 10. So we get 1, 1, 2, 4 till 10, 100. Next, we will do a word count. So you can type something in your text file and do a count on individual word. Just make sure you don't copy any empty line there, because this source code doesn't handle any empty line. And let me do a left demo how should we run this code. First, everything is set up for my machine now. I will grab my master node's public key here and change my previous. Oh, I haven't. 1 second. Join.me/oyc-open-data. You can share my screen. So the link is join.me/oyc. Open data. Mike. Who is this?
Maybe me?
David?
Oh, I see it.
You have to type your name and knock.
I'll show you the process.
Mark?
That's me.
So, just type that. I think it's easier to do cat with this one. Just type that. Or bot.
Have you all get the join me?
So you have
Yeah,
process H.
Jennifer?
And,
Sonju?
No, it's not slash. No, it's You basically opening the file.
Hence-
and so get rid of that.
Mike,
Uh,
Zhang?
Yes, so
Yeah.
it's supposed to be
And it's a .pub file.
that and was, yeah, third.
Alright, so just take this whole thing,
Lennon,
just highlight it. No, not the opposite mouse. It's not too big at all. Make sure you got the S. If you didn't get the S, then you're, no, it's not right.
do I have more gas?
Yeah, we'll just give me a second.
Just like a.
Okay, I'm switching. Have you?
No, don't put it on your back. It should be on your
This
this
side.
Mark H. We have 3 mark today.
So you're gonna do this.
Okay, sure.
And just build out this with the one.
Is it public key to join the?
Well, you can just go to the menu.
A while later, it
And here's a new session.
different public.
And then run back and forth. Sitting open in the body. 1, 2, 3, do the same thing. And then
Do I have more gas? Ben?
Yeah.
We have 20 people here. I got 14 here. And can I switch? Okay. Okay, one more. It's join.me/OYC. What's the problem?
The other browser platform.
You type your name there. She has to confirm.
Steve? Lin? Okay. Think I get almost everyone. Okay. So I first connect to my master node. And before you run any R, you should start your Hadoop. So where do we grab the code? Go to my repo and search for start your Hadoop. There is a command here. You can copy and grab. Did you find it? It's underneath of start your Hadoop. Copy paste to the remote machine. It tells you whether it start, whether the date node up, name node up. So the master one have one name node and second name node, and 2 slave will have 2 separate data node. And the master and the slave both have task tracker, so know they're running properly.
Quick question.
Sure.
Did you just say the terminology is that the master is called name node
No.
and the slaves
so-
are called data
no.
node? No.
No, if you run a function called JPS, it will give you the name of the progress you're
You're
running.
just sending it with.
That's why I'm saying you have a process called name node and process called second name node. It's the
Okay,
name of the process.
all right.
If you run JPS on your slave machine, you should have data node, JPS, and job tracker.
Okay,
Both of the slave nodes should have 3 process.
all right.
More questions? And I type R to enter R. And next I'm going to my hackpad.
in each of these 3 directions.
So I already installed all the package I needed. Step 1, step 2, step 3. And I'm going to the simple test section. I want to run the simplest one in MapReduce. So what is the syntax? First, do you know what's required function for?
For the library?
Yes, it's similar to library and the package name. So I'm loading RHDFS. Can you guess what's this stand for?
Hadoop distributed process.
That's right.
What's ER?
So HDFS is Hadoop distributed file system. And before you run anything, you need to make sure you run a HDFS initialize the environment for you. Next, I run the RMR2 MR is MapReduce, second version. And the fourth line, I'm saying I want a vector, 1, 2, 3, 4, 5, till 10. I want to transform them into a big data object, so I can use them in the Hadoop program. So it seems like it's similar to this. So if you only have R, you can define a vector 1 to 1000 and do a sapply. What sapply doing is aggregate the. So this function, or sapply function, will take individual element of this vector and apply it to this function. It's saying, I take 1 and I want 1 to 2. I take 2, I want 2 to 2. So in the end of the function, you should have a vector 1, 4, 9 till 1000 to 2. So we want to do similar things in R, but doing it in MapReduce fashion. This is the most simple Hello World version of MapReduce. So we can go back here. This is saying, please save my 1 to 10 into a big data object. And the function we're calling it called MapReduce. We're saying the big data object is passed by small.int, and the map function is written this way. MapReduce takes key and value. Right now we're not using value. We are mapping the 1 to 10 vector into V and do V squared. So let's run this one. Copy paste this session. Okay, so you can see after we load R HDFS, it tells you it depends on R Java and where the Hadoop command directory sit on. It's underneath the home Hadoop, home Ubuntu Hadoop 1.2.1 being Hadoop. And it gives you a hint. Please run the initialization function. After you run RMR, all the dependent package will be loaded too. And after you run small int to DFS, it tells you, oh, I'm running the native Hadoop library. I already successfully loaded, and I got the new compressor. So let's do a class, see what small int's for. Class help you to identify what function you can call over objects. It tells you small.int is a function. So let's copy paste it, see what's going on there. It saves the file name. So actually when you save your vector into the big data object, it's not saved in your memory. It's saved in a temporary file location. That's why you call small.int to give you a f name. It's a temporary file location. Are we good?
Let's say you just want to be looking at your data and exploring it. You're not sure what big job you want to run on it. You want to get means and basic crosstabs and stuff.
Just run this on your on your laptop?
Right. So that's what I'm saying, is that it's, before I do all the heavy calculation, am I just running an R session on the data? Or
Most of the time you couldn't, because when people use MapReduce, they really have a lot of data. Like all the Expedia price lines data. They want to know the average delay of flight,
yes.
What is the best timing for you to book a ticket.
Yes.
So those things you couldn't experiment on your own machine. This one is like, just make sure it works. This simple example.
Yes.
So next, let me do copy paste, do a MapReduce job here. So what do we expect to see?
Squared vector.
Redundant?
Squared vector.
Yes, that's right. So you notice it didn't give you the result right away because it's busy separating the job to different nodes.
How does it know which of the mapping was which node, or is it done internally?
I guess they have drop load balancer. So you can tell I'm doing how much map, how much reduce, and when it's all done, it's saved into an output file here. 10 file and file name. So that's why in the hack pack I said pay attention to your output from the last step, because that would be your function parameter. So we want to read out the result. We can copy paste the file folder, do from DFS.
Could you scale up the font? It's
Yeah,
too
sure.
small.
Big enough?
Good, scroll down.
So I'm typing from .dfs and I copy the location of the output. Then I need to do file quotation mark. So we are fetching the result from MapReduce. Okay, we have the result. It gives us a key because we didn't assign anything to key. The key is none. The value is 2 vector. Does this make sense? If you assign so if you assign the MapReduce job to a, like this, correspondingly this function can be from .dfs a. It works the same way. Because you are passing the output file location to A. Good? Okay, cool. Shall we move on? Okay, next we want to do a word count test. So you can make a file called test.word.count. You can type any random thing or copy paste any article you like. Just make sure there are no empty lines there. I already saved it in my file system. So because I mentioned Hadoop have different file systems than Linux. So when you make your own file, you need to go to Hadoop folder to use Hadoop function fs to make a folder called test inside of Hadoop file system. After that, you can copy from your local file to the Hadoop location, Hadoop file system.
So the command is Hadoop, and fs tells it I'm going to do something with the file system.
Hadoop space fs is saying I am making a directory inside of Hadoop system. After that, you can copy your local. This local means my Linux local environment. Copy it from
Okay, yeah, from local.
it to Hadoop's text folder. So most of people will miss this step and don't know why they couldn't make a file. Make sure you have it. And I'm
Sorry, can you say that again?
yes. Because Hadoop have different file system. If you just say I want to copy my local file from my task folder, and the name called task.count into Hadoop. It won't work because Hadoop file system is like different word. You need to have another task folder there before you can do the copy paste.
So what does that mean, the dash copy from local? You have to have that keyword and then.
It's a function. It's a function parameter.
Yeah.
It's like make dir, but you notice the dash make dir and the dash copy from local is like a parameter of fs. So it's saying Hadoop, I want to copy Linux local file to the Hadoop file system.
And then the test.word.count is
File.
the intermediate.
This is the file name.
So you created that file locally.
That's the name of her local file that she's copied.
Yes.
Yeah.
So you should make a file using VI to open an editor. Name it as test.word.count and save it in your like root directory of the Linux machine of your master node, so you can copy it over. Good. Okay, so I already have the file. Let me go through this function first. I first define the input is task folder task.word count, and word count function do two things.
Most of it, right?
Mm,
Feedback.
okay. So anyone want to try to understand this function and expand this one? I have wc.map, wc.reduce. Zhang, can you explain what's wc map do?
Are you taking each line on a different note, counting the words on it, and then summing it up at the end?
So let's read them step by step. First, the map function. Inside of map, we have the key value function. This is the value. We are assigning value to 1. So this will be our key. What's happened in the key part? I take each line of the article I just saved, and I'm saying please split them by the pattern I specified. The pattern is space. That means I was,
So you're breaking every line into each word.
yes, that's right. And each of the individual word will become separate vector. Like one rabbit would be one rabbit, 1. So all the words will have 1 append to them. So if in the article you have 100 words, this function will give you each word with a 1 count. So at this step, you haven't reduced them because you haven't count each word's the frequency of each word. So next, we should move to reduce. Reduce part, take all the words you just split in some counts. It's like adding all the 1 together. Good. And last function is MapReduce. We want to know where we are importing the file and where we're saving to. What's the format of the file? Which function I'm calling? Which one is my map part? Which one is my reduce part? and whether I want to combine them. And after this, we can run the whole function.
Where do you specify the arguments to get passed to the reduce function?
Because every map and reduce, internally they can pass key and value pair. You don't need to say I'm passing key and pair to the next one. They have internal they can go through. Question? Please ask me if you are confused. So
when you get the result,
Mhm.
you take the word count of your input file.
Enthusiastic.
Yeah. Why do you have to go through two steps? You have this RES, you take the word count and you take that RES and you read it from DFS?
Oh, because you notice in my function word count, I'm calling function within function. So if you are calling res is actually equal to this part, because the last line of the code will be returned back to the function call.
Yeah.
So res is actually equal to this line.
But then what does the next line do? The result is from DFS RES.
Because res is a temp file location. In order to print them out, we need to do from.dfs. We did similar thing for the square part. We say
So you could have just made that one line done from that DFS word count input,
yes,
right?
yes.
So I get how line 16 is working, but line 20, so all the nodes that are doing the mapping step
Mhm.
will return, like you said, key value pair,
Mhm.
word, and the value of 1.
Mhm.
But how does that get then reduced into?
Because mapping and reduce maps their parameter by position. The first would be key, the second would be their value. So last line of the map, you get like A1, rabbit 1, running, run 1. You get like 3 line of vector. It will be fit into reduce. So you're getting all the words with their words and the frequency. This is like adding all the one together and pass to the map reduce.
Okay, so let's say I have the word the, it's in there 5 times. Will I get the one called, and then that will increment the
That
value?
will give you dog 4, rabbit 2.
So it'll already be reduced by the time it's called.
Yes, yes. So reducing like aggregating things.
So map has only the ones.
Map will only give you the
Has
ones.
Everything added together.
Yes, but
Because of that function.
But next, later I will cover an example called key means. Before you pass map to reduce, you can do one reduce inside of memory already before you do second reduce. So Hadoop give you flexibility to reduce at different stage. This one is really simple, so we only reduce it once, but possibly you need to do multiple times.
So the MapReduce job relies on 2 steps, one of which creates a key value pair. That's the map, and the other is reducing a key value pair.
That's right.
So, because you always see the example of word counts, that maps, or well, maps, that you can use that key value pair paradigm very easily on it.
That's right.
What if I wanted to do something that was not quite so obvious?
Like I give another example, it's doing accounting on emails. Like this is the file, how it looks like. This is my email file. So using the word counts.r file, as my basis, I want to count how often I get email from different domain. So what should I do? First, I split the username before at and after at, so I can get clean list like 21cn.com 1, 126.com 1, qq.com 1. That's the math part. And I do a reduce. I count each domain, how often I get email from them. It's like upgrading your word count to the real word question. So how exactly we did that? First you read the file using read table. And you notice here we're using 1 as key data as the value. So we are appending the whole column of the email file inside of the D1. And we want to save them into, we want to print them out, how it look like. And in the reduce part, we use a function called word. Basically what it does means, after I read in the email file, MapReduce will automatically add the column name V1 to the email column. So I'm saying, please give me the email column and separate the word by at. So the first email will be split into 2 parts. It will be, after you split them, it will look like this and this. And I'm saying I want the second one. So only this part will be kept. Word function parameter 2 means I only want the second part. And this one is similar to what we have here, the word count. For each domain, I appending a 1 to the domain. Okay, so the sum is adding all the 1 up and do combine. That's the exactly same thing we did for word count.
So the key in that function, or in the mapper, right, that's being returned as the 1, basically, right? Or is it the domain name?
The key in map function is their domain name, like 21cn.com, and with a 1 as its value. So when you put the domain and 1 into reduce, it will add all the 1 up. So 21cn.com maybe 4,
Okay.
126.com maybe 5. And
So the value is, the frequency, and then the key is the domain, right?
that's right. And after that, we can do a sort. Also use MapReduce. So you notice we are using a data frame function because we want to save the domain name and the value both as value. That's why we use data frame to combine them. Next, we want to say we want to order by the V. V will be the sum, like number 4, number 5. We're resorting them and give their new index back to V. The sort and the split part is pretty similar. Are you all know R very well? Can you read this code? Good.
If you did combine equals false, then it wouldn't do the ordering.
Yeah. You need to do combine to true. But you can play with it. I will give the source code to you. So let's try to run word count first. You just copy paste everything I have here. Copy paste. Okay, it's running, streaming. You can copy the whole 100-year solitude to the word count file, or Harry Potter. Okay, map 100% done. Reduce. Going on, going on.
Vivian, are you doing this on your Amazon server thing, or are you doing this locally?
It's Amazon. You can see it's my Amazon.
The Ubuntu on the top?
What?
I see the Ubuntu thing
And
at the
this
top.
whole iPad setup is done within the Amazon station.
Yes, everything is on the Amazon. It's on my master node.
And I wasn't sure what it meant in step 5, reconnect your server.
Which step you mentioned, Mike?
Step 5 in the Mac.
Step 5?
Says reconnect your server to find.
It's here, it's in your setup.
It says in R run, but it doesn't tell you that in char.
Where?
The server.
Sorry, can you point me?
Yeah, it says, at this step, it says reconnect your server.
Yes.
It says in R run, but it doesn't say in char. on the server.
Just type R. You will
Just like
enter
R
R.
with a capital A.
Yes, just type R.
Too easy.
Yeah, that doesn't, okay. I probably did lowercase.
Okay, so we have the result. Let's print it out. So OK showed 3 times. I showed once. So this is just some random typing. Let's run the email example. I already saved the email file under my Linux machine. So there is a very good tutorial on the link of this. If you go to this guy's meetup, it's on the Revolution Analytic RMR2 repo. Click on the documents, click on tutorial. He wrote a really good tutorial. The reason I didn't use his function directly because the way he wrote them, it usually comes with a big parameter list. I was like breaking them down into different sections. But this word count basically doing the same thing I showed you in my source code. It's the same thing. So what he did is he wrapped the map reduce and the reduce inside of the word count function and passed them all at once. Let me copy paste the link to the hackpad and refer to this link. Okay, it should be done. Okay, so in my email file, I have 9 emails from qq.com, 9 from 126. You can like compile one list of your own email box and see how it look like. And I'm sorting based on how often they appear using MapReduce. Any question about the email reduce part? So basically those 2 easy examples you can make sure your MapReduce can run successfully. Because they're really small and straightforward. that's the count and sorted result. So, if you pay more close attention to the source code, you notice we use key and value differently. Sometimes we assign key as 1, value as the data we're passing. Sometimes we combine the value of previous step's key and the count of the key into the new value or key. So you need to use them interchangeably. Depends on how do you want to print out the result and which part you're actually counting. In the map part, you are splitting them and adding 1, so the value will be 1. So if you're not using key, you can either put a dot or 1 there. So just give up the key for reduce.
So all the mappers return key value pairs.
What?
All the mappers return key value pairs.
Bec-
All the
it-
map functions return key value pairs.
Yes, so when you write map function, it takes key and value from your input. You can say, I want the value equal to input, the key be empty. After they process the function definition, the result will be your new key and value for next step, for reduce. After reduce grab the key and value, it will run the function definition and spit you out the final map reduce result. So it's like, I taking something, produce it, and give to reduce. Reduce, finish something, give back to map reduce. Does that make sense to you?
It seems like R is, being used as a way of communicating with Hadoop and passing
Yes.
in data and a map function and a reduce function.
So if
And
you
then
use
do field work.
if you use R all the time, it's just like rewrite your R so Hadoop can handle it for you.
Yeah. But my problem is that all the complicated, wonderful, great things I do with R, it seems like 99% of that I can't do through this.
You just wrap them into key or value.
All my really great machine learning stuff is good at working key value. I support vector machines,
It doesn't matter. You can wrap the whole thing into value or key.
really.
Yes. Like next, I'm going to go through the k-means, logistic regression, and linear least square. The key means one is really nice, but it's really hard to read.
Okay.
Okay, so are we all good? So I covered one example on square. It's your first MapReduce job. Second is the word count. Oh, actually he did one more thing. He also ran a function count the frequency of each numbers. So the organic R function is look like this. Group, I want 50 random number from binomial distribution, and I want to know how many of them. So if we copy and paste those 2 lines and run this in R, it gives you the frequency of each letters. 7 appeared twice, 8 appeared 3 times. So the tutorial example is telling you how you can write this in Hadoop. So first you put group as your input, your values, the numbers as your key for the map function, and you do a length of key to do the reduce. Because they're all 1, length of V or sum of V will give you the same result. Length of a vector of 1 is 4. If you sum 4, 1 together, it's also 4. Okay, this is those 2 programs. We have done the word count, and we have 3 more very difficult ones. So the first one is supervised learning. specifically about logistic regression by gradient descent. Do you guys know what gradient descent for? It's calculated for local minimum. So you have a learning rate, how fast you want to convert the algorithm. And why do we use logistic regression? Logist function because the output of logist would be between 0 and 1. If you are doing classification, you want number either 0 or 1. And I also find a nice paper written by Jason Rini. Basically, every function called in the logistic regression can be mapped back to his paper. That's exactly how it's written.
Could you put the reference to
Yes.
the hack pad?
Yes. MIT paper. Here. So let's go through this. First, logistic regressions is getting parameter input iteration, like how many times you want to improve your result, dimension, and alpha. Alpha is the learning rate, how fast you want to move each step. You split the time, define your logist regression by G, and define your gradient function by input, map, reduce, and combine, and update your plane step by step. So this is the initialized part. Y times X times logist is similar to updating the weight along the way. So you need to read the formula 2 in the formula 3. It tells you G times X times Y times X times G is updating the gradient descent. It's mapping back to the code. Y times X times G.
It's a paper that she just,
And the reduced part will summarize all the steps for you.
So you just colored up the equation into the map function.
Yes, as long as you separate like the core part here, you just run it like the regular MapReduce job.
Okay, so then the calculations can move back on themselves. I mean, once the mapper did his job,
You can't go back.
you can't go back and recalculate another node if you want. You have to go forward and reduce.
So mapping is like your secretary. You ask your secretary to do multiple things, and he tell other people to do them for you. Like, he bring your jacket to dry cleaner. So their slaves will do the actual work for you.
But the algorithm, like gradient descent, it's iterative. You have to use the results from a prior calculation to continue the next one. How does Hadoop really provide a performance gain when you can't, if you want 1,000 iterations, you can't parallelize the task where one node is computing the 400th while another is computing the 200th task. You have to wait until the result from step n-1 is ready to trigger the step n.
My understanding, you can have different paths to do their converge. So you have a circle, you can converge from different
Oh,
directions.
so you're saying it's going to start at different points, and the one that's succeeding role. Okay. All right, I see.
So if we go to the wiki page, it's like you're going to your target from different direction. Okay, next. K-means. Do you know what K-means for? If you have,
It's clustering method.
okay, so based on what criteria?
The minimum distance between the center.
So it has several parts. The first part you want to specify what's the center. Like in the very beginning, you don't know center R, so you just random draw the sample from all the nodes you know. Like I have 1 million points. I sample 100 node points from 1 million. They will be my initial center. Based on the updating function, I'm adjusting the center. I'm saying, oh, this node didn't give me good center, so I'm moving to another one. So after you stabilize the distance of each cluster, you reach the final result. So that's how you actually calculate the k-means. So first, we define a function called distance.function. This part, column sum is actually counting the distance of each node. And it goes inside of map. You notice right now we have two if and else function. The first if telling you if I don't have any center, I want to sample a center from all the nodes. I'm doing a sample 1 to number of cluster. It's the initial setting. If I already have node, I calculate based on their distance function. I do a sum of all the distance in this group. And I mentioned you have option to do in memory combine or not in memory combine, which means in the map part, when you do A1, rabbit 1, wrong 1, you can do a reduce once before you pass to reduce. So if you turn in memory combine to 2, it will do combine once. So it's specifying whether you want to do extra combine task.
So what are those key values here?
It's the node you specify, the nearest node,
That's the value?
the point of the center.
Yeah. That's a key or
Yes.
value? What's the value?
Yes, it's the key of all the centroid of the point. Center of the.
Let's say we had 5, K is 5. Right? So we're trying to break up our data into 5 regions. For each
So-
iteration, are there 5? What are the 5 key values?
So, C is the center. P is all the points. We first calculate all the distance. Nearest is the last column. It's the lowest distance we have so far. You pass the distance to next step.
It's nice to look at an answer.
Yes, this steps tell you what is nearest.
Oh,
You are-
what are the keys and what are the values?
The key is nearest. Value is P. Key is the distance in the group.
So if I have 1,000 points, and I'm trying to break them into 5 regions, right? Then, do I have 1,000 key value pairs, or 5 key, how many key value pairs do I have?
You should have 5 pairs if you're breaking them into 5 groups.
Okay. And then the key would be the center, essentially.
Yes.
And the value is
The
all
key-
the points.
The key will
that-
be the distance of all the points in this cluster.
That's the key.
Yeah, that's the key.
And the value is,
Value is the point in each group. Like the first group you have 20 nodes, I'm passing the distance among this inside of this group and all the points in this group. That's why you're passing 5 pair of key and value.
Okay.
It's like a summary of what you have got so far. And based on, because the reduce doesn't know whether you do it in memory combine. So when reduce take over your key and value, it will also do a detect whether you did in memory combine. Based on whether you did or not, it handles key differently. It's like you did previously, I would need to come up with a solution based on your solution. It's just formatting result differently. Okay. In the very end, you go through all the steps and find out where is your best center of your k-means, and there is example how you update your k-means center. So the red point is the center, the black one is all the nodes. So notice in the very beginning, the center is just random, like in the middle, a bunch of red one. And you keep updating them. Can you see the red ones? This is 2-dimension. K-means can handle multi-dimension scenario.
So when you start, you don't have any predefined locations for the seeds, so you give them random variables.
Mm-hmm.
And then you go into the map step. The map step just starts finding the distance
Calculate distance.
from each of the centers to each of the points.
Yes.
And I'm assuming you're trying to minimize those distances, so either reduce the one that's actually selecting the cheapest or the lowest value.
It will pass to all slave. It will pass to all slave. Say which slave can find the best solution. And they will communicate each other. And if I say I find center for group 1, I can tell all the other nodes.
Okay.
But it's hard to say until the very end of their calculation. Because like if you use k-means in the past, you notice every time you do k-means you might get different result. Like the iris dataset. Even you run the same k-means multiple times, it still give you different center, different grouping. Right? As long as the distance is good, we're good to go. Even they give you different grouping. Okay. So the last example, we have 5 more minutes, and I can work around, help you set up your own R Hadoop environment. So when do we use linear least square? If you have huge matrix, like you have all the data from Facebook, all the friendship relationship, how can you calculate whether your friend and your fiance or your wife's friend are friends? I mean, predict whether they are friends. You want to solve the huge matrix. That's why you want to use linear least square. Basically, you're doing solve matrix solution. So every code underneath is doing this. You can do this one line in R. Okay, so how does that work? First, you have a random matrix, have 2,000 numbers. That would be 200 times 10 matrix. And you assign an index to x dot index.
I thought that would create a matrix of 10 columns, no?
10 columns,
200 rows.
200 rows.
Right.
Mhm. So less reduce is similar to sum. It's like I'm adding all the one together. And you have the XTX part using MapReduce and the XTY part using MapReduce. The only tricky part is in the map part. How do you calculate X time product X? You notice if you compare those two parameters, the only difference is here, yi and xi. Because you're doing x times x and x times y.
So
The rest-
in MapReduce, you cannot use usual matrix like multiplications or inversion. You cannot use usual function at all.
I tried on my machine. I have 8 GB RAM. I can only do 1,000 times 1,000 matrix solve. If I have huge matrix, I won't be able to do it.
So that means if you have more than 1,000 customers data set, then you cannot run just usual regression.
You can run regression, but this is matrix calculation.
So for matrix calculation,
Is you want to get this.
okay.
This is very heavy computation. It's not like regression. Regression is you calculating the coefficient.
Yeah.
It looks like, but I think this is much heavier, this one, because it relate to eigenvalue calculation. Because once you turn this into solve tx times x, it's like t to t. You will have much bigger matrix. I don't know how to say it, but I'm pretty sure the computation cost is different from linear regression. Yeah, it looks like linear. Okay, so our one more example. So there is a famous data set called airline. You can get this from I think it's 20 years airline data, like what time they were leave, the scheduled time leave to departure and arrival. And you can calculate which flight line you should fly with. Like their flight is most on time. This data set is more than 38 gigabytes.
It's
So-
just free to download.
It's free to download.
Could you also put the reference?
Yes. Flight data, big one. Okay. Also, you have all the freedom to parallel machine learning algorithm. Like this one is implementation for finding frequent item set. Like you have all the transaction data from Amazon or Target. It's like the diaper bear one. This is the actual implementation. Maybe we can find some free data to do frequent item set. And I think most of you have seen this picture. It's Facebook social network. This plot didn't put any shapefile of the Earth. Everything is drawn based on latitude and longitude. And this graph consists of up to 10 billion elements, including all the nodes and edge. So you can use R. Actually, the guy who made this used R to draw this plot and MapReduce. Yeah, I think that's it. I will start to help you to go through this tutorial and the hack pack tutorial.
For the last classes tutorial, I got difficulty to read how to do in the configure the environment, configure core site file.
Oh, someone, Lyndon just mentioned, because Markdown got translate, if you click on the row, you will find out I put a tag like how actually you can configure the core site. Because when GitHub translate my Markdown, this part was took out.
You click on the name of the file,
Click on the row.
and you click on raw.
Oh,
They have.
oh, I see.
So sadly, there's all this away.
Good.
So much.
Give it a try. I hope you can finish everything until the sample test today. So you're all set. You have all the environment I have. Yes.
Question, so this is it's a lot of work to set all this up, and then once we shut down the Amazon instance, are we paying for the storage that's underneath that?
Yes,
You have to, right? You can't store anything for free on Amazon.
that's right,
They must be charging for something.
yeah.
If you deactivate an instance, they still charge you.
Well, they don't charge you for the running instance, but there's storage underneath that, right?
Yeah.
When we set up the instance, I didn't choose add storage. If
But
you,
the instance itself uses something like 8 gigabytes of
Yeah.
what's called an elastic block storage volume,
And
which
you must get charged for that,
ultimately amounts to space in S3.
but
And you do get charged, it's very small.
for the 24
but
gigs, which is
Is
240.
it 24? Okay.
Well, 8 times 3, right? I don't know if it
Right.
does it expand, or is it you charge for 8 gigs?
You charge for the 8,
So you'd be charged for 20 per gigs a month,
yeah,
if that's sitting there and you don't remove it,
that's right,
even if the instance isn't running.
that's right.
Okay.
Yes.
I have another account, I didn't use the instant very much. They charge me about $9 every month.
Yeah.
But I have multiple instant there.
Hmm.
So I guess it won't be too much.
Yeah, not much, but the point is
Yeah.
you do incur something.
Yes, but you want, because you already put so much effort into this, you want to start to use it. Even you're
It's
not
a
using,
subscription.
even you're not using MapReduce, you can still host your RStudio server Pro there.
Hmm.
You can program everything on the cloud.
I feel like I need to learn R just because I did all this work.
You go for the class.
Does it change your IP addresses every time you shut it down? or-
You can pay for the non-changed IP.
Okay.
You can use your fixed IP.
But before, I noticed I was,
So either we have
before I
free
was shutting
running or-
down and restarting, it was the same, but when I shut
Only
down
used
after I
free
set everything up.
Is that what you're using?
I
As
see.
soon as I got here, I had to like go back into my host files and put in the new IPs.
These instances are not in free tier.
So if you like install RStudio server there, you just specify which portal you install your RStudio server, and you can use it at your local RStudio. And you can set up your admin. Like I'm using this for my R class, so
That's
on
right.
May 1st they will do the demo project day. All of you are welcome to come.
Requirements for.
Do their parents come too and they get little stars and?
You were there last time,
No.
so.
When that happened.
Back to the stuff.
So this is the event we planned for the R003 class.
Take these
Um, This is the session they will present, Craigslist data, Wikipedia data.
Wikipedia, how can I get Wikipedia data?
You can download the whole Wikipedia JSON file. It's around 80 gigabytes.
8 gigabyte?
The whole Wikipedia file, the whole Wikipedia website is a JSON file. So in Africa, they don't have web, they don't have internet. They just save the whole JSON in their iPhone or other phone. They can do the Wikipedia search.
Oh, okay, cool.
Yes, those are my students in the R003.
Okay.
They are going to present like how you can analyze the election in Turkey, forecast the rain down to minute, the paper relationship on the archive website. So it's May 1st. we will use the RStudio Pro. I just set up the crowd account for each of them.
Colon. That would do.
Okay, should we get our hands dirty and try things out?
Oh, that was for
Well,
all.
this is letting, so you say, it is authorized keys. This is saying anything that tries to connect to me with this key, let it in. Without
Okay.
password.
I
So next you just
didn't
say,
realize it was read
now meetup 203 can connect to meetup 1, no problem, assuming this is meetup 1. So we
Okay.
just do the same exact thing on the meetup 2, or the other two instances. There's actually an easier way to do this than because you're not in .sh. Market shape.
Guys, I will stay for a half hour more. I hope you finish all the configuration. You can run the square at least.
And the raw file editor really shows the
Right,
key
so VI is just like sitting there
part.
in command mode right now.
With what?
The GitHub, yeah, did it show all the details about?
Yes, because when GitHub translate the markdown, take out all text, the HTML text, I need to find another way to put it in. I didn't realize that till this morning.
Yep.
You notice when I quit my R, all the HDFS was released, all the 10 files.
So I've assumed that this is